Solving special systems of linear equations. All right, so today we're going to look at some special scenarios. First, let's look at the standards and the success criteria. So today you need to be able to determine the number of solutions of a system. You need to be able to solve a system of linear equations with any number of solutions. Okay, so if you remember in the previous lessons, we have solved by graphing, we've solved by substitution, and we've solved by elimination. All right, and sometimes you see special cases, and that's what we're going to look at, some of those special cases in this lesson. All right, so if you solve a system of linear equations, a system of linear equations can have one solution. So if they intersect, the point of intersection is that solution. That's what we've been studying in the previous lessons. No solution. So if they are parallel, if they have the same slope but different y-intercepts, then they are considered parallel. They will travel at the same slope forever, which means they will not cross. So those system like that case would have no solution. Or infinitely many solutions. Infinitely many solutions means you have two equations that have the same line, the same slope, and the same y-intercept. Everything in the equation is the same. So it may be written in a different form, but if you change one equation and put it in the same form as the other, you're going to see that they have the same slope and the same y-intercept. All right, example 1, solving a system with no solution. All right, solve the system using any method. All right, so if we look at these two equations here, we can quickly see that they have the same slope. They have the same slope in the different y-intercept, so we know, or you should know, that these are going to be parallel lines. They're never going to cross, so there's going to be no solution. All right, so let's look at what that looks like algebraically. Okay, you could graph those, but we also can set those equal to each other using substitution. So let's say 2x plus 1 equals 2x minus 5. All right, and then if we subtract 2x from both sides, we get 1 equals negative 5. All right, we all know that 1 does not equal negative 5, so that's a false statement. If you get a false statement, that means that can never happen. So that means there is no point where it would make both equations true at the same time. So there is no solution to this system of equations. All right, a study tip, a linear system with no solution is called an inconsistent system. A linear system with infinitely many solutions is called a consistent or dependent system. All right, you can solve some linear equations by inspection. In example 1, notice you can rewrite the system as, all right, so if you wanted to rewrite this in standard form, you could do that. And this system has no solutions because negative 2x plus y cannot be equal to both 1 and negative 5. So if they put this in standard form, you can see this left side here is exactly the same. And it's saying this is equal to 1, and the same thing is equal to negative 5, and we know that cannot happen. So I did pretty much the same thing using substitution, setting the two equations equal. This is another way you may look at it as well. Example 2, solving a system with infinitely many solutions. All right, infinitely many solutions means it has all their points in common. So every point on the graph will be the same as the other equation. So let's look at the two equations. So we can look here and see that if I multiply the top equation by 2, that's going to give me the same thing as I have here. If I multiply this by 2, it gives me the same thing I have here. And if I multiply this by 2, it gives me the same thing I have here. So that's called an equivalent equation. So let's do that. So let's multiply the whole equation by 2. 2 times negative 2x is negative 4x. 2 times y is 2y, and 2 times 3 is 6. All right, if we bring down the second equation, we can see that we have the exact same equation. So if we graph these two lines, it's going to be one graphed right on top of the other because it's the same line essentially, which means any point I choose that is a solution for one equation is also going to be a solution for the second equation. So this would mean that all real numbers would work for this system of equations. So that's why there are infinitely many solutions. All right, self-assessment. I want you to take a few minutes, pause the video, and see if you can find the best way to see how many solutions each of these systems have. So it says to solve the system and explain your choice. So you know you can do graphing, you can do substitution, you can do elimination. Which system are you, or which method are you going to use for each of the three systems? Once you have time to do that, come back and we will talk about the answers. All right, hopefully you took time to do these on your own. Let's see how you did. All right, this one's very similar to one we've already done. I took the first equation and I multiplied it by 2. And I can see when I do that, I get the same equation as the second equation. So these are equivalent equations. Basically, they're the same equation. They were just written a little bit differently. This one was just 2 times larger than this one. So when we multiply the whole equation, both the left and the right side, we get the same equation, which means every point that I plug in to these two equations will have the same result. So that means that this one has all real numbers. That also can be written as negative infinity to infinity. That represents your all real numbers solution. All right, the second one, I decided to use substitution. Since y was already solved for in the first equation, y equals negative x plus 3, I took that and plugged it into the second equation for y. So I have 2x plus 2 times y. Y is negative x plus 3 equals 4. Then I distribute the 2. And when I do that, I have a 2x and a minus 2x on the same side of the equation. So 2x minus 2x cancel. That means I bring down my 6 equals 4. 6 equals 4 is a false statement. That is never going to be true. So this one is no solution. All right. The third equation, I decided to solve the first equation for y by quickly subtracting 5x. You may have used a different method, and if you did, that's perfectly fine. Hopefully you got the same answer because you should get the same answer no matter which method you use. If you do it correctly, you're going to get the same answer with any method. All right, so this is the method that I chose. All right, so I'm going to have x plus 6 times y equals negative 5x plus 4, so I'm going to substitute that in, equals a 9.5. I come down through here and simplify. I get x equals 1/2, and then I get, when I plug in 1/2 up here, then I get y equals 1.5. Okay, so instead of writing this as a fraction and this as a decimal, I'll change the 1/2 to 0.5. So hopefully you know that 1/2 and 0.5, two equivalent expressions, and then so 0.5 and 1.5, that's my x and y value. So this one has one solution. There is one solution for number 3, and that one solution is 0.5 and 1.5, or 1/2, and this would be 3/2. If you wrote it as 1/2 and 3/2, again, that's the same thing. That's a different way to write the answer, just an equivalent expression, and that would be correct as well. All right, the last example, solving real life problems. You buy 1 bag of dog food and 2 bags of treats online for a total of $48. A few weeks later, you buy 2 bags of the same dog food and 4 bags of the same treats for a total of $96. Find the price of each bag of food and each bag of treats. All right, so you can see that unless they've raised the prices, these are probably equivalent equations, but let's set up an equation and see what happens. So we're going to say let x be dog food, I guess. Let's see. So let's say X is 1 bag of dog food, and Y is going to be bags of treats. All right, so you buy 1 bag of dog food, so 1 bag of dog food plus 2 bags of treats, and that equals $48. So there's our first equation. A few weeks later, you buy 2 bags of the same kind of dog food, so 2X again, and 4 bags of the same treats, so 4Y again, and that's going to equal $96. All right, find the price of each bag of food. Okay, we got to find X and the bag of treats, which is Y. So we need to find both X and Y. So when I look at this, it looks like both of these numbers are double this. So let's multiply this by a -2. Sorry about the screen there. I got too close to the edge. All right, so if I multiply this by a -2, that's going to give me a new equation of -2x minus 4y equals 48 times -2 is going to be 96. All right, so -2 times 48 is -96. So now I have 2x plus 4y equals 96. Looks like if I add these two equations, I'm going to get, this is going to cancel. -4 plus 4 will cancel, and this one will cancel as well. So I'm going to get 0 equals 0. So that means these are equivalent expressions. So these are going to have, every solution is going to be exactly the same. So in order to find the price of each bag of food and treats, I'm going to have to use a different method to solve. So let's try graphing. All right, so if we're going to graph, let's graph using our intercepts. So let's take our first equation. So we've got 1x plus 2y equals 48. And we know that these are equivalent equations, so we just have to find the intercept for one equation, and we know it's going to be ultimately the same line. So if we find the intercepts for one, we're finding the intercepts for the other one as well. So remember, if we find the intercepts, we got to plug in 0 for x, solve for y. All right, 4 divided by 2 is 2, 8 divided by 2 is 4. So when x is 0, y is 24. So that's one of our intercepts. Now let's do the same thing for the other one. So we're going to have x plus 2. This time y is going to be 0 equals 48. This cancels, so x equals 48. All right, so when x is 48, y equals 0. So 48, 0 is another one of our intercepts. All right, to save a little time, I went ahead and brought the graph over so you can see that we found the intercept of 0, 24. So when x is 0, 24 is a solution. And we found the other intercept to be 48, 0. So when x is 48, y is 0, that's the other solution. And you can see that this line represents both of these equations. Any point on this line will tell you how to find the price for dog food and a bag of treats. Because of the nature of this problem having infinitely many solutions, where it says find the price of each bag of food and each bag of treats with all the points being exactly the same, there is not enough information, okay, because there's so many points that correspond to this line. There's not enough information to determine the price per bag. So we have solved the problem, but as far as answering this question here, we cannot do that since these are equivalent equations. All right, that's all for example 3. If you have questions, please let me know.